This is January 2022 for the Pure Maths Paper 1R from Pearson Edexcel IGCSE. Let's just do it. So we're drawing lines here. So when x is 0, y becomes 4 if you solve this. So this goes through 0, 4. And when y is 0, x is 5. So it goes through 5, 0. And you get the line like this. And likewise, you can do the same thing here. You get your 2 points on the axis, and it looks a bit like this. And then show by showing the region. So we've got this. So we're below this first line, which was this one. So below this. And we're above this. And then this is just the line y equals 3, which is a horizontal line across here. And x equals 1 is a vertical line there. We're going to be below this one and to the right of this one. So that's going to be clearly this region just in here. And that will be our answer. Good. Number 2 then, the nth term of this is this. So it's an arithmetic series. So it starts with a and then goes a plus d. And then the next term will be a plus 2d and then a plus 3d because you're just adding d each time. So the 5th term, which is u5, is a plus 4d. So a plus 4d is 46. And the 20th term is u plus 19d. That you always have one less d than the term number. Do this one minus this one, and we get this. Divide by 15 for this. Put it back into here for this, and we have all that. Then you break out the formula book, like I guess. We're looking for the sum from the 21st term to the 50th, which is the same as the sum from the first term to the 50th minus the first 20 terms. That will just leave behind the 21st term to the 50th. So that's what we're going to set up. The formula booklet says this. So the sum from the first 50 terms, you just put 50 in here with a is 10 and d is 9, as we saw before. And then the sum to the first 20 terms, you just put 20 in here. And then again, a is 10 and d is 9. Type that all into a calculator, and we should end up looking like this for our answer. 3 then, you can draw this if you want to. So there are the 2 points. You've got a line connection them, I guess. Now we've got a perpendicular bisector, so we need the midpoint of this line, which just average the x coordinates, average the y coordinates. 1 plus 9 is 10 over 2 is 5. 7 plus 3 is 10 over 2 is 5. So we've got a point 55 in the middle. Perpendicular bisector intersects this at 90 degrees. And therefore, if we think about the gradient of this original line, so gradient of this line, well, it rises up 4 places from 3 to 7 and runs across 8 places from 9 to 1. So the gradient is rise over run, that's 4 over 8, but it's also negative because it's going in this direction. I'm not sure what those red lines are about. Oh, I'll get to those in a second. Anyway, so the gradient of this line is minus 4 over 8, which can simplify, of course, to minus a half. And therefore, the gradient of this line, which is perpendicular, is positive 2. It's just the negative reciprocal of this one. Y minus y1 equals mx minus x1 now comes along. We know the point y1 and x1 is 5, 5, and that simplifies to that. And now it says we cross this this line here, crosses the x-axis at c. So it crosses the x-axis when y is 0. So plug y is 0 into this equation here, and you get x is 5 over 2, I should say. And it wants the area of the triangle ABC. A is this point, B is this point, and C is this point. There's a couple of ways you could do this, but what I decided to do was work out the length of the line from A to B by doing Pythagoras. So as we saw before, it goes across 4, it goes up 4 and across 8. So if we do a 4 squared plus 8 squared, we get this, and rooted, of course, because it's Pythagoras, we get that from a calculator. And then this one here, so it goes across from 2.5 to 5, that's 2.5 across, and it goes up 5. So if we do 2.5 squared plus 5 squared, square rooted, we'll get this, again, from a calculator. And then because this is at 90 degrees here, these two lines, to find the area of this, we can just do a half times this times that, half times base times height, and we'll get our answer. Again, just typing stuff into a calculator to get that. Now this one here, so the area of a sector if the angle's in radians is r squared theta over 2. I don't think that's in the formula book actually, so we have to just know that. So, well, it's broken this OA into 3 to 1. So if this is r and this is 3 to 1, then this is 3/4 r and this is 1/4 r, because that way this is 3 times that. And the area of region R is going to be the area of the sector minus the area of the triangle. Now the area of the sector, again, like I said, is r squared theta over 2. The area of this triangle is a half AB sine C. A, B, and then sine of this. So that's A, that's B, and that's sine of pi over 3. Now, so sine of pi over 3 is root 3 over 2. So when you multiply all that together, you get this. And then you can factorize out the r squared and do 79.5, which you get given, from the question, divided by all of this. You get that, you square root, and it's basically 20. And then the perimeter of the region R, so the arc length is just r theta. So we're just going to do 20 times pi over 3 for the arc length. And then this length is just 1/4 r, which is just roughly 5. And then this length here, we can do cosine rule for. We can just do db squared equals this squared plus this squared minus 2 times this times cos of that. type it into a calculator, press square root, and you get this. And then add up this result, and this result together. So the nearest two sig figs is 44. 5 then, so I mean, I'm not really sure what the point of this first question is. It's literally just asking you to copy down this, but with x being ax, and that's literally all it's asking you to do. So we just get that. So I'm not really sure what the point of that was. The expansion, the x coefficient, I think I tidied this up a little bit to look more like this, just sort of separating out the x squared and the x cubed. The reason I did that is because it says the coefficient of x is 8, so therefore an is 8, and the coefficient of x squared is 30, so all of this is 30. So I can solve this for a and n, obviously, because it's just a simultaneous equation. So here, just divide by n, and then square both. Here I times everything by 2, sorry. Here, divide by n, and then just square everything, and then just put that result into there. And this n will cancel with one of those to just leave you with a divide by n. Times everything by n here, and then expand out to 64, and you get this. And then you can just solve this. N is, I think, 16 if you do that. And then shove that 16 back into here, and you get a as a half. And then you can use those two results. It's looking for the coefficient of x cubed, so just use those two results and put them in there, and just type it straight into a calculator, and you get this. Question 5 then, when it's about vectors, I tend to just draw it. Let's just pretend p is at the origin, because it doesn't make a difference. So p to q is 2i plus 3j, so that's 2 across 3 up, so that looks maybe like this. P to r, again starting at the origin maybe, because I'm just pretending p is at the origin, is minus I plus 18j, so that's up there. And then p to s is minus 3i plus 15j, so that's over there somewhere. So we can label all that. And now we're aiming to show that this is a parallelogram. So let's think about q to r. Well, to get from q to r, I could go minus this vector plus this vector, just thinking about geometric things. So minus this plus this. If you drew this on squared paper, you could literally just count across. But anyway, let's do minus this plus this. That's minus this one plus this one. And we end up with minus 3i plus 15j, which is identical to p to s. So therefore, this vector is equal to this vector, which means they're parallel. And so that's half the work done. Now let's consider s to r. S to r is just going to be minus this vector plus this one. So that's minus this one plus this one, I think. And so that's minus this one. Yeah, that's minus this one plus this one. Yep, cool. And we get this, which is equal to p to q. And so therefore, this vector is the same as this vector. And of course, if the two, all a parallelogram needs to have is two pairs of parallel sides. And they do, clearly, because they have two pairs of identical sides opposite each other, which is more than enough. Actually makes it, no, it just makes it a parallelogram, right? Yeah. Anyway, both pairs of opposite sides are parallel, that's all you really need to say. Unit vector q to s. So q to s then, just do minus this vector plus this vector. So that's minus this plus that. So do that for q to s. And you end up with this. And then you can find the length of that by just doing Pythagoras. And you get 13, because we all know the 5, 12, 13 triangle. And so to find a unit vector from here to here, you just divide this vector, which is its direction, by its modulus, which is 13. And we end up with this unit vector here. P to t, so t is somewhere between q and s, such that we have 5 parts here and 8 parts here. So, okay, to get from q to t then, we just have to times this little bit by 5, because we've already broken q to s into 13 little pieces. Here they are. So let's just times those by 5. The sum of this ratio is, of course, 13. So just times this by 5, and you get q to t. And then, of course, to find p to t, just do p to q plus that little thing we just found. P to q is just this, so we add those together. We add together the i's, we add together the j's, and you end up with this here as our answer. 7 then, so a very classic question here. The surface area is going to be this side plus this side, so that's 2 lots of a half times 3x times 4x. And then we're going to have plus 4x times y for the base, plus 3x times y for this back bit, and plus 5x times y for this slanted bit. So we get all of that. That simplifies to that. Now, I notice there's no y's in here, so let's rearrange this for y by just doing that. When you divide by 12, you're going to end up with 12 minus x squared all over x, but I'll deal with that in a second. The volume is just a half times 3x times 4x times by y. So we just get this. This is, of course, 6x squared, I believe, times y. And y is written as this, dividing that by 12 successfully. X squared over x is just x, so we end up with this 6 times 12 and so on, and we get this, which is what they were asking us to show. Now we use some calculus, so dv by dx, this just makes 7t2 minus 18x squared. We're going to solve this for 0 because we're trying to show for a maximum. Maximum must be a stationary point at the least, so we're going to need to get dv by dx to be 0. Of course, add this to both sides, divide by 18 square root, and we get x is 2. And then we need to show it's a maximum. So let's find d2v by dx squared by differentiating this again, which just leaves us with minus 36x. When we put in x as 2, we're going to get minus 72, which is less than 0, so therefore it's a maximum. And find the maximum value of v, so we just take this value that we know produces a maximum, and we put it in v, and we find our answer of 96. Maybe I should have put some units on, but I couldn't be bothered. A curve has this equation, the point A is on such that the x-coordinate is this. So okay, let's put the x-coordinate in here, and we end up with this, and therefore sine of pi is 0, so y is just 2 pi squared, so that's the coordinates of A. And now if we differentiate this, we'll get the gradient, because it's asking about a normal, so we're going to need to think about gradient. So dy by dx is 4x minus cos x. And then at the coordinate x is pi, just put pi in here. Cos of pi is minus 1, so that makes minus 1 is plus 1. So you get this. The normal is the negative reciprocal of this gradient. So the gradient is 4 pi plus 1. So the normal is 1 over 4 pi plus 1 with a negative in front. So that's the gradient of the normal. And the normal goes through this point still because it says so. So now let's just do y minus y1 equals mx minus x1. With this is x1, this is y1, and this is m. And if you sort this out in an intelligent way, you should get exactly this. I think I just flipped over this thing here, just timesing both sides by minus 1. Then I multiplied out here, but I didn't actually multiply. I just multiplied this one by that and this one by that because I'm trying to get the stuff that's up on this answer line here. Add this to both sides, take away this from both sides, we end up with this. And so that's looking pretty accurate. And then here, you can expand this out and then factorize out the pi. And of course, to keep these minuses, you have to change these to pluses when there's a minus outside the brackets and write it out exactly the way they want it, and you'll get all 8 marks. Good, 9 then. So, okay, 2 marks for just typing stuff into a calculator, so that's pretty nice. And then another 2 marks for plotting some coordinates nice and carefully, which I sort of didn't actually do, but I did at least plot them. I wasn't careful about it. And then putting a curve through them, which looks roughly like this when you bother to do that properly. And then by drawing a suitable straight line. So there's a couple of ways of doing this. It's by far the hardest question, not only here, but also probably on this paper. What you want to do is you've got this sketch of this here. So you want to draw a line on this picture here, and then you're looking for the intersection of the two, and that's going to be your estimate. So somehow out of this algebra, you need to make this. So okay, if I just move these two terms over to the other side, and also add maybe 15 to both sides, I'll end up with x cubed plus 4. So I've just like unsimplified this in a very specific way to get x cubed plus 4 on the top. And now this is quite nice because this side just factorizes. It just factorizes to this. And then if you divide both sides by x minus 5, but actually divide both sides by negative 5, x minus 5, because that way this one will kind of flip over and go over here. Maybe I haven't explained that very, very nicely. I've actually divided by 5 minus x. But and of course, when you divide this side by 5 minus x, you get this. But when you divide this side by 5 minus x, 5 minus x is just negative x minus 5. So those two things cancel and just leave behind a negative here. And now, of course, this can expand out. And what this is really asking here is, where's the intersection between this curve and this line? The line with equation y equals 3 minus x, and the curve with equation y equals this. Like if you were asked this, the first thing you would do is set them equal to each other. You'd make this, and then you do a bunch of simplifying, and you get eventually up to here. So I'm essentially just doing this question all backwards in order to get to this question. And now I can just draw the line 3 minus x, which looks like this, gradient minus 1 minus f of 3, and see that the answer is approximately 1.3, and we'll have our answer. The other way you could do that is you could just say, okay, well, where does this curve here intersect a line ax plus b? And then you can work through this. So multiply by 5 minus x, expand out, collect together. And what you want is you want this to be that. So, okay, the x cubes match. A must be minus 1 to make that match. And then if a is minus 1, you get b plus 5 here, which means b must be 3 to make that match. And then, of course, that's the line that I was looking at before, right? Minus 1x plus 3 is the line that we decided earlier. So that's the other way you can think about it if you wanted to. Anyway, 10 then. So factor theorem works both ways. So to show that this is a factor, you could just say, well, f of 3/4 x is 0. If f of 3/4 x is, if f of 3/4 is 0, then 4x minus 3 is a factor because 3/4 is a thing that solves that. Usually you do that the other way around, but factor theorem works both ways. That's fine. So let's just work out f of 3/4, and we end up, of course, with 0, and so therefore 4x minus 3 is a factor. So the formula on page 2 are these formula. So sine of 2 theta is obviously just sine of theta plus theta. And then according to this formula, that's sine theta cos theta plus sine theta cos theta, which is 2 sine theta cos theta, so that's nice and easy. And then this one here, cos 2 theta is just cos of theta plus theta, which according to this theorem is cos of theta minus sine of theta sine of theta. Of course, that's just cos squared, that's sine squared. Sine squared is 1 minus cos squared, according to the holy grail of all identities, and then you can expand this out and you end up with this, which is the right-hand side, and we're done. Show that the equation this becomes this by that substitution. I mean, firstly, just get rid of these two results, this one and this one, via these two things. That's what I did first. Then I did a bunch of expanding. Pretty boring stuff. I wrote sine squared as 1 minus cos squared again. Then I did a bit more expanding. Then I did some collecting, and we got to here. And yeah, if you make this substitution x equals cos theta, then you end up with 16x cubed plus 11 plus 11x minus 15 equals 0, which is what they wanted you to get. Hence show that any solution of this is given by this. Well, this we just decided could be written as this with the substitution. So that's there. This from earlier can be written as 4x minus 3 times something else, because 4x minus 3 is a factor. Now, you could do some polynomial division if you wanted to get this, or you could just be more intelligent and say, well, if this factors to this and this, 4 times 4 is 16, so that's got to be a 4, because there's no other way to make x cubes. Minus 3 times plus 5 is minus 15, there's no other way to make a constant. If I call this plus ax and look at the x squared terms, there are none of them over here. So 0x squared equals minus 12x squared plus 4ax squared. Those are the only ways to make x squared here. So we get this, and then we get a is 3. And then we have our fully factorized thing like this. And so if we're solving this to be 0, which is therefore this to be 0 under the substitution, and we're just solving this to be 0 because that's the factorization. Of course, that means that x is 3/4, which we already have. Cos theta is 3/4. That's the one they're asking me to get. So that's all fine. This here, if you think about the discriminant, b squared minus 4ac, it's actually less than 0, and therefore has no solutions, and therefore this is the only solutions set you're actually going to get here. Question 11 then, so find the value of a. Well, a is on the y-axis, so x is 0. Put in x is 0, you just get 1 minus 9, so that's minus 8, obviously. Here, you're on the x-axis, so y is 0. So you put y is 0 into here, you add 9, you take log of both sides. You divide by 2, by power law, this half can go up here, and then 9 to the half is 3, and you end up with what they wanted there. The region R is rotated around the x-axis 360 degrees, so we're going to do pi integral of y squared dx between the two limits, which is 0 and log 3, as we just discovered. Y squared is this squared, that's e to the 2x minus 9 times brackets e to the 2x minus 9, so a double bracket here. E to the 2x times e to the 2x is e to the 2x squared. 2x times 2 is 4x, so that's going to be e to the 4x. Minus 9x squared is minus 18. Minus 9 e to the 2x times minus 9 plus minus 9 e to the 2x is minus 18 e to the 2x, and then a plus 81 at the end. We can, of course, just integrate this. This integrates to a quarter e to the 4x. This integrates to minus 9 e to the 2x. You're just dividing by these numbers as you integrate. That integrates to 81x. Put the limits in, and you get all this. That 4 can bounce up to there, doing the opposite of the power law we saw earlier, and this 2 up to there. Of course, when you put in zeros, these just become 1s, and then that becomes a 0. So that tidies up to that, I think. This bounces up here. Now we can cancel the and the log. You can't do it up here. You have to move this out of the way. So now we can cancel these, and we end up with this, because 3 to the 4 is 81, so that just becomes that. 3 squared is 9 times 9 is 81. Put together those three things, and you end up with this, which will be the answer. Thanks for watching. Cool.